Hey everyone, today I'll be doing the T1W9 Mechanics Quiz. So I'd like to start off by saying these are your equations. Please memorize them. Very, very, very important, okay? They are very important and we will be using all of them. 6 equations. Well, actually 6 categories. You have like 12. Okay, now 3 of them you can derive, and I derived 2 of them in the regional group files group if you're in it. So I derived this and this, but I wouldn't recommend deriving. It's 2 pages long and it's annoying to do, and obviously you don't have time for this in the exam, right? So I'd really recommend memorizing them, and they're very, very easy. For f of x, right? For fx, it's equal to 0, and for fy, it's equal to, I mean, this is core knowledge and you barely even need to use it, right? So since it's moving at u or m at the x-axis, you're gonna have 0 acceleration, right? U or m, constant velocity, right? But for y here, you have an acceleration. What's this acceleration? It is negative g. All right, so now v of x, okay, it's gonna be v0 cosine theta, right? Because remember, when you split up a force into its components, right, like you have a force f here, okay, and you have theta, right? Fx is gonna be f cosine theta, and fy is gonna be f sine theta. All right, so this is where we're gonna get cosine theta and sine theta from. V0 is gonna be our f essentially. All right, so this is whenever you see sine theta or cosine theta with a v0, you initially know this is the y component of the initial velocity. So here, v of x is equal to, since the velocity stays the same, it's u or m, right? The velocity is gonna stay the same, it's constant. It's gonna be the same exact thing as the x component of our velocity, of our initial velocity. So this is what we write. This is essentially v of x, v of 0x. Okay. Now here we're gonna use the UARM equations. V is equal to AT plus V0, right? So A is negative G, T we have it. This is Vy of 0, right? So this is V0y. Okay, now this is also the URM equation, right? This is the URM equation. Delta x equals Vt, right? Now the initial equation was what? X equals Vt plus x0. But you take x0 to the other side, you get delta x equals Vt, right? And what is V? Remember, it's this V of x. So it's going to be V0 cosine theta times t, all right? Now, delta y, it's the UARM equation, negative half AT squared plus, what was it? V0t plus y0. But you take y0 to the other side, so you get this as your equation. All right, now max height and the abscissa of the max height. So this is the x coordinate and this is the y coordinate. All right, it is what do you call it? It is these formulas. You memorize them, you want to derive them. I said the derivation in the group, so feel free to know. And this is the formula for the range. If you notice, right, it is double. It is 2 times the formula of this. So if you wanted to memorize it, just do 2 times v0 squared sine 2 theta over 2g. You're going to get v0 squared sine 2 theta over g, right? Because the 2 and 2 will cancel out. So these are your formulas. Please, please, please screenshot them. Very important. Now let's move on to the quiz. Okay, question 1. A projectile has been launched in vacuum near the surface of the Earth. The origin, Okay, so a projectile has been launched in vacuum near the surface of the Earth. The origin is chosen on the ground with the y-axis pointing upward. Which of the following can be variation of the y component of the velocity? Now remember, we said the y component, so Vy is what is changing at a constant rate. Why? Because acceleration is constant. So that means that velocity, right, the slope of it's going to be a straight line. Okay, now let's look at the graph of projectile motion in general. It's like this. Okay, so what is happening here? Look, it's slowly, like you're always gonna have your highest velocity at the initial point, right? Because over time it's slowly gonna decrease. You can look at the slope of the tangents, right? Because how is it gonna get flat here how is it gonna get flat here and then start going negative, and then negative without a decrease, right? Like for example, here you're gonna have it very steep, then here slightly less steep. Look, it's this, like you can't see it because my graph is small, but this part here is gonna be steeper than this part. And remember, so that means what this is initially just means our velocity is decreasing with time, right? But our velocity is what? Our velocity is changing at a constant rate, so it's a straight line, right? So we need a graph with a decreasing velocity at a straight line. This graph is staying constant. This graph is in terms of the fact that it's decreasing. Okay, that's correct. But it's also a straight line. That's also correct. However, they said that the y-axis was initially upwards. And remember, how are you launching up, right, with a zero velocity? Doesn't make sense. Okay, so initially you are gonna have a velocity with a number, right? You're gonna have, for example, 6 meters per second. This was launched at, right? So then it's gonna go down. How are you launching something into the sky, right? And you're starting off at zero. The object just isn't moving, and it doesn't make sense. So this graph is wrong, and the other graphs, this one doesn't make sense, right? Because it's going down, then it's going back up. It doesn't make sense because remember we said it's going down at a straight line, and this one's going up and it's going down. Doesn't make sense either. Now, as for the v of x, remember we said it's urm. So velocity is what? Velocity is constant. So it's just gonna be a straight line, which is this one. Okay. Or straight line, sorry, no change at all. Like it's just gonna be one value, which is what's happening in this graph. Look, the velocity is staying the same at any point. So this is the correct answer. Now for question 3, the acceleration, remember, the acceleration, okay, it can be, it's always gonna decrease, right? Because look, remember our graph is like this, okay? Now, we're moving, anyway, we are moving at what? We are moving at UARM in terms of acceleration. We're looking at acceleration, we're gonna look at the Y part, and it's constant, right? It is constant. Now, remember, we said that our graph, it's gonna be decreasing. And anyway, we don't even need to know all this. Remember, acceleration was what? Acceleration was equal to negative g. So this is negative. We need a graph that is negative and is going at a line like this. We need no change in our acceleration at all. This was changing. This is changing. This you can see it's going down, then it's going back up. So this is wrong, leaving this one as the only correct answer. And this one the same thing. All right, that was question 1. Okay, question 2 is also very, very easy. They want you, this is all blah, 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 blah. All they're asking you is, describes the variation of horizontal velocity. Horizontal velocity, what is it? We're moving horizontal, that means x, v of x. This is urm, right? Urm means what? Constant velocity, right? So the velocity will stay at a constant value, which is the only graph that shows us is this. This is the graph of like a trajectory, maybe the trajectory of the graph, right? This is the trajectory of the projectile motion in general, right? So this is the variation of y and x. So this is wrong. This is the correct answer. This is wrong because here you can see velocity is changing. So this is wrong. This is wrong, and this is wrong because they're all changing. Figure B is the only constant one. Question 3. Okay, for question 3, it's very easy, right? So first of all, we're gonna draw an axis. Why? Because they're giving me north of east and north of west. So we're already gonna use Mariner's compass. Okay, so N, south, east, west. Now, A is given at 31 degrees north of east. So 31 degrees north of east is this. Now, B is given at what? 65 degrees north of west. So we'll say like this, 65 degrees. Okay, and this is here 0.5, 0.8. Okay, now, let's find each case first. So we're going to take A first. So I'm going to erase B. Now, they want the speed of B relative to A. So in relative motion, there's like rules that are common sense and rules that aren't. For this one, you really need one, is B relative to A, all right? It's gonna be the velocity of B minus the velocity of A, all right? So, how are you gonna do this? Stay with me. So, velocity of A, we're gonna find it first of all. We're gonna find in terms of I and J, again. So, it's gonna be 0.5. Wait, sorry, I forgot to put V of AX, right? We're going to separate it into AX and AY. So 0.5. Now remember, when we said X, it's always going to be F cosine theta, right? So V is our F, which is 0.5. Cosine, oh my God. So it's fine, no problem. So V of AX, okay, it's going to be 0.5 cosine 31 degrees. Okay, let me just draw the axis back. So here 0.5, 31 degrees. Okay, so 0.5 cosine 31, let me get a calculator. So 0.5 cosine 31 gives you 0.43, let's say 0.43 I. Okay, now V of AY is going to be the same exact thing except with sine. So 0.5 sine 31 degrees. This is going to equal to sine 31 degrees. You get 0.26 J. All right. So V of A is what? 0.43 I plus 0.26J. Okay, now this is for A. For B, okay, so let's draw it for B now. B is like this, 65 degrees, 0.8. But we need the angle from here. So what's this gonna be? It's gonna be 90 plus, what's 65 minus 90? 65, 90 minus 65. This here is 25 degrees, right? 25 degrees. So let me change the color. This part here, this angle is 25 degrees. Okay, this is 90. 90 plus 25, 115. So this whole angle is 115 degrees. All right, so what you're gonna do now is you're gonna write V of Bx is equal to 0.8 cosine 115, which gives you 0.8 cosine 115, negative 0.4, negative 0.34, sorry, negative 0.34i, right? And V of By is equal to 0.8 sine 115, which is 0.72j. All right, now we're going to subtract these two from each other. So do I minus I, 0.43 minus 0.34 gives you 0.09. Sorry, let me draw it here. 0.09i. Okay, now 0.26 or plus 0.72, because remember this one's positive, plus 0.72 gives you 0.98j. All right, now to find the resultant, it's gonna be, remember, the magnitude of the resultant is what, x squared or I squared plus y squared, right? So we're gonna substitute 0.09 squared plus 0.98 squared. Now this gives you an answer of radical 0.09 squared plus 0.98 squared gives you 0.98 meter per second. Okay, this should be the answer. 0.9. Yeah, this is the answer. 0.9 meter per second. They just took it to one decimal place. That's fine. All right, this is the answer. Now, moving on to question 4. All right, now question 4 is the application of the last two formulas I explained in the first start of the video. So range. Now, first of all, before I start solving anything, a projectile is launched at a projectile is launched at an angle of elevation alpha given by tan alpha is equal to 5/8 at the speed of 70 meters per second. Okay, so first of all, this is V0, right? This was the speed it was launched at. Now, they give us tan alpha. We need to find alpha. What do? We do the inverse tangent. So tan negative 1, 5/8 gives you 32 degrees. All right, now the range, what was the formula? The range is equal to V0 squared sine 2 theta, or 2 alpha in our case because they named it alpha, 2 alpha over G. Alright, so just substitute in the values. 17 squared sine 2 times 32 over 10, because they told us to take G as 10. Alright, you do this, it will give you 25.9. So 25.9, you round it to 26 because they wanted to the nearest integer. Done. Okay, now part B is the maximum height. Remember, the maximum height is very easy. It's basically similar to that formula. So max height is equal to V0 squared sine alpha squared over what? 2G. Alright, the only difference here is that we took the 2 up and made it a power, and we added 2 to the G. Alright, or multiply G by 2. So doing this, you will get 17 squared sine 32 squared over 20. You'll get 4.05. They set to the nearest integer, so you round to 4 meters. That's your answer. Done. Question 5. Okay, for this question, what you do is you start off by writing, so this is relative to the wind, right? This is relative to the wind because it's, air. So B of car to ground, or sorry, car of to wind is what? 0.8 meters per second. All right, now the velocity of the wind to the ground, right? Because the wind is always going to be to the ground, right? It's going to be 1.20 meters per second. Okay, so now you can express this in terms of ing, right? Because they're perpendicular to each other. So say the car is going like this, okay? Then the wind will hit it like this, okay? So What does that mean? This forms a right triangle because they're perpendicular to each other. Okay, that means it's like this. This is the velocity. Okay, so what do? You apply the magnitude, right? This is going in, let's say this is I, right? Because this is going in a certain direction, like this, for example. And let's say the wind is J, right? So 20J, okay? Because remember, the car can stay still. So you can let it be like this. It's fine. You can also let it be like this. I'm gonna decide that this is the car. But then this comes the wind like this, right? They're right triangles, right? So there's only I and J. So 0.8 I, so this is the car here, and the wind is here. Okay, so the car is what? Only 0.8 I, right? Because you're only going towards the X direction. The wind is 1.20 J. Why? Because it's only going towards the Y direction. So what is the magnitude of this? Because you're gonna add them up and you're gonna find the magnitude. So the magnitude of so this is gonna essentially be the resultant. The answer is gonna be the resultant. It's gonna be 0.8 squared plus 1.2 squared. This gives me, so under a radical, 0.8 squared plus 1.2 squared. 1.44 meters per second. Done. Okay, question 6. Okay, question 6, I'm not even going to read any of this. All I need to know is g is equal to 9.8 and the rest is given to me in the graph. So, here you have 30 degrees as your theta, and you have V0 as 15. So, first of all, what do they want? They want the initial vertical component. How do you find this? The vertical component. So, what do you do? V0 sine theta. What was V0? V0 was 15 sine 30. Sine 30 is 0.5, so 7.5 meters per second. Okay, part B. How long does it take how long does it take the stone to reach point Y? Now, if you notice here, let's say this is X, okay, and this is Y. Look, there is no change in Y, right? Delta Y is 0. That's what you can use. Delta Y is equal to 0. Why? Because this is the Y at X and this is the Y at Y, the Y coordinate, like this, the Y axis, right? They're at the same, the Y value. So the change in the Y is 0. Right? So what we're gonna do, remember the formula is what? Delta Y equals negative half GT squared plus V0 sine theta T. Now, delta Y is equal to 0. Negative half GT squared. This is 9.8. So negative half 9.8 T squared plus V0 sine theta, we just found it. It's the vertical component, right? 7.5 T. Okay, now you can take this to the other side, this part here. Why am I back here? You can take this to the other side, so it's gonna give you half, okay, into negative, positive half, yeah. 9.8 T squared is equal to 7.5 T. Right? Cancel T with T, T squared with T, you'll get, I'll move it up here, half of 9.8 times T is equal to 7.5. Alright, so now you're gonna divide 7.5 by by half of 9.8. You're gonna get T is equal to 7.5 over 0.5 times 9.8. Okay, this gives you 1.5. Let me change the color. 1.5 seconds. All right, the answer is 1.5 seconds on the calculator. Okay, so it's basic algebra. You're just rearranging the equation and taking it to the other side. You should know how to do this, and you'll get 1.5 very easily. Okay, part C. What is the height of the cliff H? Okay, so we're gonna use delta Y again. Why? Because look, what they told me is the total time of the flight of the stone is 5 seconds. So we know at 5 seconds, this is here, right? So look, you have the value of H, right? You started here and you came here at 5 seconds. So this is height, right? So what you're gonna do is, you're gonna find delta Y. Delta Y is equal to negative half GT squared plus V0 sine theta T. Again, okay? Now, delta Y is equal to negative half of 9.8 is 4.9. So negative 4.9 into 5 squared, because look, the time is 5. 5 squared is 25 plus V0 sine theta, we found it part A is 7.5 times 5. This gives you delta Y to be what? Negative 85 meters. So you might be asking, the answer is 85. But why is negative 85? Because look, we set the Y axis to be up, right? Because you're always taking the Y axis positive in the direction you're moving initially. The direction we're moving at the very initial start is what? Up. Right? It goes up. So so Y is positive. But بعدين it ends up going down. Right? So that's why it ends up going down here. Right? So delta Y is going to be in the negatives. Obviously, you can tell from the graph, right? It started here, then it went here. What is this? This is a negative change. I went down. And how much did I go down by? By H. So h is equal to delta y, which is equal to, or absolute value of delta y, which is equal to 85 meters. Okay, done. Very easy, very simple. Question 7. Okay, so a golf ball is projected upward with a launch angle of 15 degrees. This is theta. Initial speed of 72 meters per second. This is v0. First of all, if it's not given to, I always like to start by drawing a graph of my projectile motion. So I have it going like this, just so I can visualize what's going on. Let me draw it better. So, oh my god, that's not better. So I have it like this, okay? This is slightly better, it's fine. This is 15 degrees, right? 15 degrees, and I have 72 here, 72 meters per second. All right, perfect. So the time that it will take for the golf ball to reach the top. Okay, so here, the top, you're gonna use something, you're gonna use the fact that, for example, here you have y and you have x, all right? Now, this like the tangent to any point on this graph is gonna represent the velocity, right? Let's say the max is here, the max height's here. You can look that the tangent is flat, right? I can't draw it perfectly, but the tangent is flat, right? So that means what? The velocity at the max height is equal to 0. And we're gonna use that fact, all right? The Vy at max height. Why? Because the velocity of x, right? It's gonna remain constant. Always, always, always it is constant. Never forget. Okay, perfect. So now that we know this, we can apply the equation. Remember the equation, Vy is equal to negative gt plus v0 sine theta. All right? So Vy is 0. So 0 is equal to negative gt plus v0 sine theta. Now, personally, I like taking gt to the other side because, again, I'm explaining for some people who might not have an equation solver. If you have an equation solver, just plug in your values directly and solve for time, right? But if you don't have an equation solver, you're basically forced to take gt to the other side. So you're going to have gt is equal to v0 sine theta, okay? Now, so I'm just rearranging so I can solve it straight away. So that means what? T is equal to v0 sine theta over g. All right, so let's find all of this. So plug in these values directly. V0 is what? 72. Sine theta is 15 over g. They told you use it as 10. So over 10 gives you 1.86 seconds. You round to 1.9, which is what they want. All right, so part B, the maximum height attained by the golf ball. Okay, since I erased my graph, let's draw it again. Probably better than the last time, hopefully, maybe. So yeah, this is a better graph. All right, so the max height here, we're gonna do the same exact thing we did in the last problem, which is what? We're gonna use the formula, right? Personally, like, this is the easiest thing for you to do. So the max height is equal to v0 sine squared theta over 2g. Okay, so this is gonna equal to, let's do it. So 72 sine what is the 15 squared? So 15, close the bracket, then squared. Mind that, because sine of 15 squared, sine of 225 is different than sine of 15 all squared. So sine of 15, close your bracket, and then squared over 2 times 10, which is 20, gives you this is wrong. What did I do? Wait, give me a second. Oh yeah, wait, I forgot to v0 squared. It's v0 squared. So 72 squared. 72 squared times sine 15 squared. So 72 squared sine 15 squared. You'll get 17.36 rounded to 17.4 meters. Right. This is why it's very, very important to figure out these formulas. Because look, a tiny mistake. On the first time, without getting the 72 squared, I used 72. I got 0.24 meters, which is obviously wrong. So even a tiny, tiny error like that for getting the square, it can cost you the entire question. So please be mindful. Okay, this is another relative velocity question. So it says that the Falcon is flying west. All right, let's draw. Actually, let's not do that. Falcon is flying west, so this is west, right? Now, and the wind is pushing south. So again, another right triangle. Okay, so the Falcon is moving at 105 meters per second, and this other guy, the wind, it's moving at 10 meters per second, right? So the wind of the Falcon relative to the velocity of the Falcon relative to the ground is the velocity of the Falcon relative to the wind plus the velocity of the wind relative to the ground. Okay, so, but this is not what we're doing, by the way. This is just a formula. Now, the magnitude is the value that they want, right? So the magnitude of this is gonna be, let's call it magnitude of V of FG. Okay, it's gonna equal radical 100, or sorry, yeah, 105 squared plus 10 squared gives you radical 105 squared plus 10 squared gives you 105.4. 7.47. It's around to 105.5. All right. So that is the speed of the Falcon relative to the ground. All right. So that's 105.5. Now the angle between V of FG and the west direction. Now this is actually negative 105 I minus, or sorry, this is for the Falcon, right? And the wind is what? Negative 10J. Why? Because it's moving. This is the negative x direction. Remember, the positive is east, and then the positive for the wind, it's gonna be north, right? But we're moving south, so it's negative 10J. It's negative and negative. So that means let's call the angle alpha. Okay, alpha is equal to the inverse tangent. Sorry, let me write it with more space. Alpha is equal to tan inverse of it's gonna be j over I, right? Because it's y over x. So 10 over, or negative 10 over negative 105. This will give me 5.44 degrees. Now they rounded it to 5.5. I don't know why, but yeah, that's close enough. 5.5. It's the correct answer. All right. So that was question 8. Question 9. Okay, this is a very, very, very similar question. So the boat, all right, the boat is moving at the river like this, north at 10 meters per second. Okay, this is the boat, 10 meters per second. Now, the water is flowing east at 3 meters per second, all right? So you're gonna do that addition thing again, and I'm gonna skip it. The formula is very easy. So it's gonna be the volume of the boat relative to the shore, okay, is going to equal to the velocity of the boat with the water plus the velocity of the water with the shore. All right, so this is just vector addition. Now the magnitude, so you're going to add I and J and J. All right, you can do that, and that's what essentially we've been doing the past questions with relative velocity. But I'm skipping the step and I'm going directly to the magnitude. Why? Because this is already in terms of J, right? This is 10J. All right, and this is 3I. Right? So this is gonna be V of B to S is gonna equal to 3I plus 10J. And then you find the magnitude of this. So it's gonna be radical 10 squared plus 3 squared gives you 10.4. Alright, so this is essentially what we've been doing, right? We've been finding the magnitude, but I've been skipping the step because they're already, you can infer that they're in terms of I and J, because when it's in Y and only in Y, they tell you north or east or whatever, it means they're going straight in the north direction, east straight in the eastern direction, whatever. So it's not like going at a line or anything at an angle. No, it's going exactly at the axis, right? So you can always say I and negative I and J and negative J. It doesn't matter. So you can initially skip this step when you're working with it. But if it's a written part, never skip this. Always show this and always show this, essentially. All right. So then you find the magnitude of this. You get 10.4. That's fine. So now the angle is very, very easy. It's going to be the inverse tangent of 10 over 3, because it's, remember, it's y over x, or j over I. All right, so now doing this, you will get tangent, inverse tangent of 10 over 3. Sorry, why did I get syntax error? Okay, yeah, that's why. You'll get what? Oh wait, inverse tangent, I did tan. Tan inverse of 10 over 3 gives you 7. Did I draw this line? I don't know if I did. 73.3 degrees. This is the correct answer. This is equal to inverse tangent of 73.3 degrees. Done. All right, now question 10. Question 10 is another projectile motion question, and it's actually one of the ones that need you to kind of think, right? Not think, you're applying formulas, but you need to know how to apply them. Okay, so the range, it's the same exact formula that's always been. So V0 squared sine 2 theta over G. All right, so V0 squared. So V0 is what? 550 meters per second. So 550 squared. Sine 2 times the angle is 30 degrees, 2 times 30 over g. G is 10. 26,197 meters. That is the correct answer. All right, part B. Part B is this is the part where it's some people might get it wrong. Now, they changed the initial speed, okay? And they set the same initial angle, so theta is equal to 30, right? Takes 3 seconds, so time is 3 seconds to hit the ground, and then 0.4 below its initial point of projection. What does this mean? This means delta y equals negative 0.4, right? Because it went below, all right? So now, determine V0. We have delta y. So, negative 0.4 equals negative half of gt squared plus V0 sine theta t. Okay, so this means negative 0.4 is equal to negative of 10 times 3 squared is 9 plus V0 sine 30. Sine 30 is 0.5, right? Theta is 30, sine 30 is 0.5. The time is 3. 3 times 0.5 is gonna be 1.5, right? Now, without an equation solver, you can very easily solve this. And actually, let's solve it without an equation solver. Negative 0.4 is equal to negative half times 10 times 9, negative 45 plus 1.5 V0. Alright, so now you're gonna take negative 45 to the other side. So what's 45 minus 0.4? You get 44.6. So 44.6 is equal to 1.5 V0. Alright, divided by 1.5, you get 29.7, and that is your answer. Now, with an equation solver, you don't even need to do these steps. Plug this in straight away. Just plug this into your equation solver. Leave V0 as x. You'll get the answer. Done. You don't even need to do anything. All right. Now, determine the maximum height. Y max. All right. So we found V0. We have theta. We have t. We have everything. So y. So the height is equal to, or let's say y max. So let's see if it's y max. That's what they wanted. Y max is equal to what? I'll write the formula up here actually because I need the space down here to work. So y max is equal to V0 squared sine theta squared over 2g. Okay, so V0 squared, V0 is 29.7 squared sine 30, close the bracket, then square over 2 times 10 because g is 10, 11.02, and the answer is 11.021 decimal place. That is correct. Okay, so now question 11. Okay, this question, you just need to know how to work with equations, all right? So, they want you to find the equation. So, what do you have? You have V0, you have theta, you have g. Okay, all you need is so x. Now, here they're trying to trick you. Why? Because you have the equations, they taught you how to do it, and I told you how to do it, in delta x. Okay, now this might sound tricky, but it's really not. Why? I'll tell you why. So, delta x is what? V0 cosine theta t. Now, what is delta x? Delta x is x minus x0, right? So, you can take x0 to the other side and just say x is equal to V0 cosine theta t plus x0, right? But remember, it's launched. So x0 is 0, right? Because you're launching it from the origin. So this is wrong. You're taking the initial point where you launch it from as the origin. Always. This is how you do it in projectile motion. Okay, so you're gonna erase this. So this is the same exact formula. Doesn't matter. X, delta x, you can memorize it however way you want. This is just essentially the way to memorize it. Now, V0 cosine theta t. Now, V0 is 20. Cosine 53 degrees t. We don't have t, it's fine. So x is equal to 20 cosine 53 is literally 12.0. So we're going to say 12.03. So it's fine. 12 t. Done. Okay. Now, always, this t squared is nothing. Why? Because remember, there is no t squared in the equation anyway. It's u or m. So it doesn't matter. There is no t squared. Right? This is the only equation for u or m that you're supposed to know for this chapter. Where do you see t squared in this equation? You don't. It's gone. Okay. Now, we found that x is equal to 12t. So 12t. Was there anything added to it? Was there plus 7, plus 8? No. So this is also nothing. 12t. X is equal to 12t. This 0, 0 is just extra, yeah. Okay. Now, you're going to do the same thing for y, but you're going to do it using the other equation. So delta y or y, because again, delta y is going to be 0. Y is equal to negative half gt squared plus v0 sine theta t. Alright. So y is equal to negative g is 10, so negative 5 t squared plus, remember, because g is 10, negative half of 10, negative 5, plus V0, which is, what, V0 is, what was it, 20? 20 sine, let's find 20 sine 53. 20 sine 53 is 15.9, we're taking it as 16t. And then there's no y0, because it was launched from the origin, so plus 0. Alright, so now you're going to substitute this, exactly copy paste, negative 5t squared, 16t, and 0. Done. Easy. The time that the projectile remains airborne. Okay, so a projectile is launched in meters per second up. Take g and consider the initial. Okay, whatever, blah blah blah. That's fine. The time that the projectile remains airborne, we're gonna use this equation, right? Because when it lands on the ground, what is y gonna be? Y is gonna be 0. Delta y is gonna be 0. So y is negative. Delta y is gonna be negative 5t squared plus 16t, right? So you solve this with the polynomial. What is it? Mode 5-3. So take everything to the other side. 5t squared minus 16t is equal to 0. So 5t squared minus 16, or and the calculator will be represented in terms of x. So you do mode 5-3. So you're gonna write 5x squared minus 16x. You're gonna leave the third term as plus 0. It's fine. You're gonna get the first one as 3.2, which is correct, and 0. The second one 0. The second answer 0. It's gonna be rejected. Why? Because you already know this, right? Because what are you telling me? Like, look here. This is my graph. It's initially at 0 anyway. I already know this. I need to find this time here, right? This answer is rejected. Always, obviously, if I'm launching something from the start, the time's gonna be 0. That's when I start recording its launch. So you're gonna take the non-zero answer, which is 3.2. That's my correct answer. Now, the range is the formula. So V0 squared sine 2 theta over G. Okay, so V0 is 20 squared, so 400. Sine 2 times, what was it, 53? Sine 2 times 53 over G is 10. You get 38.45. To two significant figures, so you're not gonna round anything, because 38.4 doesn't round. 38, that's correct. Now, question 12, do they accept 38.4? They accept 38.4. All right. So, question 12. Same concept. So, a river flows due north, okay, and the man is rowing the boat across the river. Okay, so like this. Now, the river is 1,000 meters wide. All right, so okay, this question is actually very tricky. So, because it's way harder than it looks. I had to pause the video because I realized I was solving wrong for a second. So, a river flows north with a speed of this. Okay, so the river is flowing like this. All right, that's perfectly fine. We've established this very reasonably. Okay, now a man rows the boat. Okay, the river is 1,000 meters wide. Okay, so the guy is rowing the boat east. Right, so he's rowing the boat east. Okay, at 2.4 meters per second. I'm talking about part A. However, look, the thing is pushing on him. The river is pushing on him up, right? So it's gonna push him up. So his graph of motion is not actually gonna be a straight line. It's gonna actually be something like this. Okay, so the other side is here, right? He wanted to go here, right? A straight line, but he ends up here. Why? Because the river is pushing on him. All right, this is logic, common sense, common thinking. Okay, so now, the rowing velocity of this guy, okay, is 2.4 meters per second. Okay, and he's trying to cross 1,000 meters wide. He's trying to cross 1,000 meters. Now, what is the formula? Time is distance over speed, right? We're gonna need to find time. Okay, because distance isn't the distance of where he's sailing. This is something else, right? The distance is the river's distance, right? So time, because this is how much he sailed. The distance is how much he sailed. The distance he sailed, which is 1,000 over the speed is 2.4. Okay, this gives you 1,000 over 2.4, 416.67 meters per second. Please, no one starts with it. I swear to God, if I see someone in the comments. This is seconds. Okay, now the distance, okay, is gonna be how much the water pushed them up by, right? So how much are you drifting by? Let's call this the north drift, okay? Because he's drifting north. It's gonna be 1.2 times, because each second, imagine each second the river is pushing you up, the river is drifting you up by 1.2 meters per second, right? So 1.2 times the time, which is 416.67. Okay, so this is gonna be 1.2 times the answer 500, exactly 500 meters, and that is the correct answer. Okay, because imagine it, you're sailing a boat, you're trying to get from here to here, but this river is pushing on you, so you'll actually go somewhere here, right? So it's each second it's pushing on you. Okay, now for the angle, part B. Okay, the angle, it's if you want to reach directly east, right? So like if he actually does want to cross it in a straight line, what's he gonna do? He is, right, remember it's 2.4, he's sailing at 2.4. Okay, and in order for these forces to cancel out, right, they have to be equal, right? So 2.4 has to equal 1.2. But how? He's gonna have to shift the angle he's sailing at each time, right? So we're gonna write sine theta or sine alpha, whatever. This is just thinking and math at the same time. So sine theta is equal to 1.2 over 2.4. This is equal to 0.5. Like initially, you don't even need to think about the sine of theta when it's 0.5. It's 30 degrees, and that's the answer. Okay, question 13. A body of mass 5 kilograms is thrown upwards with an initial speed of 20 meters per second. Take G as 9.8 meters per second. Write your answers to one decimal, please. Okay, so it's thrown upwards, right? So it's thrown upwards, then it's gonna go back down, right? So the highest point, it's gonna be delta y is equal to negative half of gt squared plus v0 sine theta t. Now, this is interesting because what is theta? It's not given. Well, it actually is. It's very sneakily given. Thrown upwards means it's thrown upwards like this, right? So this is 90 degrees, right? This is the x and this is the y. 90 degrees, right? So sine theta is going to be sine 90, which if you know your trigonometry, this is just going to be 1. So it's going to equal to negative half of 9.8 times, how much was t? T is not given. Oh wait. Oh, no, you don't need to do this. T times by 2. No. The highest point, remember, it's going to be velocity is equal to 0, right? So Vy is equal to 0, right? So this means that Vy, which is what? It is negative gt plus V0 sine theta, right? Still holds up. The logic is still the same there. So Vy is equal to negative 9.8 t. Oh my god, there's nothing. Wait, no. Give me a second. What I've been doing is completely dumb. Why am I doing this? Max height is a formula given to me. You can derive this formula for the millionth time, and that's essentially what I've been doing without realizing it. You'd use simultaneous equations, but that's useless. Okay, so R is equal to, or sorry, what's R? Max height is equal to V0 squared sine squared theta over 2g. So now you're going to use this. V0 squared, remember, theta is 90. So V0 squared is 20 squared, which is 400, times sine 90 squared is going to be 1, because you can try it on the calculator anyway. Sine 90 squared, whatever, over 2 times 9.8 gives you 20.4. Done. That's the correct answer. All right, now part B. The time needed to reach this altitude. Now you use Vy, okay, is going to equal to negative gt plus V0 sine theta. Okay, so wait, why didn't I do this from the start? I mean, no, this is fine, this is perfect. So 0 is equal to negative gt plus V0 sine theta. You rearrange algebraically. I'm going to solve on the equation solver. I'm tired of rearranging. It's the same rearranging you will be doing for 3 questions. So 0 equals to negative 9.8 times time, which is x, plus V0, which is 20 sine of 90. This gives you time to be 2.0 seconds. That's correct. Okay, the time it takes to reach the body half the maximum height. What? The time it takes to reach the time it takes the body to reach half the maximum height for the first time. Okay, so the maximum height is 20.4, right? It says the first time. So we're gonna accept the smaller value of time, right? So delta y is gonna equal to what? 20.4 over 2, which is what? 20.4 divided by 2, 10.2 seconds, 10.2 meters. Right, so 10.2 is equal to negative half of 9.8 times t squared plus V0, which is what? 20 sine 90, which is 1, into t, right? You do this on the equation solver, or again, you rearrange and solve for it there. So let's find 10.2 equals negative half of g t squared plus 20x. Okay, this gives you 0.59, which is 0.6. Okay, so this is the correct answer. That's done. This is the answer for this question. Okay, for this question, the second part, this part is very easy. My bad, someone was at my door. Okay, so the first part, the first part, this part WI is very easy. The first part I needs a bit of thinking. So I'm gonna solve this part actually first. Now, the greatest speed attained by the ball while it's airborne, the greatest speed is always the initial velocity. So at this second, at t equals 0.000000001 seconds, this is gonna be the greatest speed, okay? So it's essentially the initial velocity. What is the initial velocity? 25 meters per second. Always, when they tell you the greatest speed, always say the initial velocity. Now, the speed of the ball at the topmost position on its trajectory to the nearest integer. Okay, now, topmost point here, right? So, it's a bit confusing. Vy, you know here, the slope of the tangent here is what? It is 0. So, that means there is no change, there is no vertical velocity, there's no Vy. Vy is equal to 0. Alright? Now, Vx it's constant. Vx is always going to be V0 cosine theta. So, Vx is going to be V0, which is 25 cosine 37. 19.96 you round to 20 meters per second. Okay, 20 meters per second. This is the greatest velocity. Now, because it was at the topmost point. However, if they tell you, for example, at t equals 7 seconds or t equals 8 seconds, I don't know. Okay, you're gonna find the Vy. Okay, you're gonna find the, let's call it y. Okay, let's call it y. Okay, and then Vx. Let's call this one x. Okay, then you have to find both of them. They tell you at a certain point that's not the vertex, that's not the highest point. There's gonna be both a vertical velocity and the horizontal velocity. You find both of them, and then you find its magnitude, which is again radical x squared plus y squared. Okay, do this if they want a certain point. But here, remember, Vy is 0, right? And Vx it's constant at 20. So it's gonna be خلاص there. You don't need to find it because it's gonna be radical 20 squared. The radical and this cancel out, 20. Done. But if it was at a certain point, you find Vy, you find Vx, you do the equation of the magnitude. This is a very, very important tip. I have a feeling they might ask it in the exam. I'm not sure. Now, trajectory has its own formula and it's very, very annoying. Trajectory, please memorize it. Trajectory, okay, is equal to tan theta x, okay? So tan theta x plus, this is the annoying part, or sorry, minus g over, okay, I'm trying to memorize it, I'm not really sure, g over 2v0 squared cosine squared theta x squared. Let me write it up here, okay? Let me write it in a clear format. So trajectory, let's say it's t, it's gonna be tan theta x minus g over 2v0 squared cosine theta squared or cosine squared theta, whatever, x squared, okay? So this is a very, very important equation and it's very annoying to memorize, but you have to. I'm sorry. So first of all, let's find tan theta. Theta is 37 degrees. So tan of 37 degrees, 0.75. So they wrote it in the other way around. It's fine. They wrote it the other way around. That's absolutely correct. So they took the tan theta on the second part and this long part as the first part, okay? So tan theta 0.75. Okay, this is the first part. This is done. Now the time for the annoying part. Negative. Okay, negative. How much did they tell us to take g as? I'll take it as 9.8, I'm assuming. 10. Okay, perfect. So negative 10 over, so let me write it again. Negative g over v0 squared cosine squared theta in brackets x squared. Okay, so negative 10 over v0 squared, which is 25 squared, cosine, negative 10 over v0 squared, which is 25 squared, cosine 37, close the bracket and square it, you'll get negative 0.0125. Okay, this is perfect, done. Oh wait, I just realized. I did it correct on my calculator, but here I forgot to put the 2. There is 2 v0 squared cosine squared theta, okay? So doing this, doing negative g over 2 times v0 squared times cosine squared theta will give you negative 0.0125 x squared. Okay, so this is the correct answer for this. Okay, question 15. If question 15 decides to load, by the grace of God, I'll unpause it when it loads. Oh, perfect, it loaded at this time. Okay. Okay, for this, it's a bit annoying, but it's very easily done. Okay, so here, the angle above the horizontal at which it was launched at. So here, look, you can see at this point, 20, and this is 0.5 seconds. Okay, or sorry, 20 and 0.5 meters. All right, so this is 20 meters, 0.5 meters. So the angle, remember, the angle is what? Tan inverse of y over x, right? So theta is equal to tan inverse of 20 over 0.5. Okay, this gives you theta as 88.5. 88.56, sorry. So you round it to 88.6 degrees. That's how I got it. I'm pretty sure there's another way, but this is the easiest way for you. Just look at the point where it crosses. So you can also do it, for example, why is it not letting me get out of this? Okay. You can do it at other points. So let's try this point here. Will this work? No, it's fine. All right. Yeah. So just do it. Do at the initial point. You can do it at the start. It's fine. Like where it's closest to a straight line, which is at this point here. This 20 and 0.5. Now the initial speed. Okay. The initial speed. It isn't that hard to get. Why? Because you already have this, and there are other ways to do it. So for example, okay, the way you do it, you find the slope that they gave you. The initial speed of the projectile is 40 meters per second. How? Because remember, the the slope of the tangent is gonna give you the velocity, right? So try it here. Let's take it here, and let's take it here. So 80 minus 40 over 2 minus 1, because this is 1 here, 1 which is 40 meters per second. Right, done. Now, you can obviously use other equations, right? This is again, why can you use this? Because look, it's the tangent to the trajectory at the origin. So that means it's at the velocity at the origin. That it's the velocity at the origin point. What is the origin point? We call it the velocity at the origin point. We call it the initial velocity. So if they give you the tangent to the velocity at the origin, or the tangent to the trajectory at the origin, they're telling you this is the line of the velocity. Alright, so this is what they're telling you. So you can find it like this. Alternatively, since you have the angle, you can always apply the equations of motion, but you really don't need to. Now, the time that the projectile remains airborne, you're going to do delta y equals negative half of, they told you use g as 9.8, t squared, plus v0t, which is what, 40 sine 88.6, okay. All of this is multiplied by time. Now, this delta y is going to equal to 0. Do this on your equation solver, right? So, or do it on the mode 5.3. So, negative half times 9.8. The calculator will do the work for you, by the way, if you do negative half times 9.8. And here I will put 40 sine 88.6. Okay, now, I'll get the first x. Okay, I'll get x to be 8.16. Wait, what? 8.16. They say use. Did I do it correctly? Wait 1 second. Okay, yeah. I think it's because of multiple choice question. They rounded down. They literally rounded to 8. It's fine. Yeah. Okay, you get 8.16. You rounded to 8 seconds. All right. So this is the answer to this question. Okay. So you're gonna use the equation of motion for the last part. Second part, you're gonna use the slope. And then the first part, you're gonna use this and this. By the way, you know what I'd recommend doing? Since this isn't very reliable, right? Here and here, because again, if you take it at any other point, it would be very, very, very unreliable, right? Because just so happened that this is almost ideally a straight line. So that's why it worked. But what I'd recommend doing is finding the initial speed and then solving for the thing, this, whatever you call it, the angle, all right? You can probably use this point here, or you can use any of these points, whatever. You can figure it out. It's application of the formulas. Question 16. Okay, so for question 16, it's essentially a special case of projectile motion, okay? So here, you have a plane or helicopter, whatever. I don't really know what it is. I don't know what do I care. It's a helicopter, okay? It drops a box, okay? And this box, it's gonna get dropped like this, okay? Like, look, it's gonna go like this. All right, so this is where the box is going to end up finally at the final interval. Now, the time it takes the box to reach the ground given to one decimal place. Okay, so it's dropped at the height of 120 meters per second. So when it reaches the ground, what is delta y going to be? Delta y is going to be 120. All right, so 120 is equal to negative half of g. G is what? G is 10. Yeah, okay. So 10. Okay, whatever. So let's repeat this. So 120. I don't want to. Can I close this? Thank you. 120 is equal to negative half times 10 times t squared plus. Now, here's the tricky part, right? V0 sine theta t. Right? Because we're applying an equation of projectile motion. Now, it says no initial vertical speed. So V0 sine theta, this is Vy, right? Vy, they literally told us 0. So what does this mean? It's 0 times time. What's 0 times time? 0. So this is our equation, right? So now, very easily do this on an equation solver. Okay, so 120, or mode 53, 120 equals to negative half times 10 times t squared. Gives you t is equal to, why can't you solve it? Okay, maybe like this. What is impossible about this? Why can't you solve it? Okay, wait. Yeah, no, it's totally right. Because look, again, why do we take it as negative gt squared? Why do we take it as negative half of gt squared? Why? Because it's initially being launched up, then down, right? This is when we conventionally take it as half gt squared. That is the best parabola I've ever drawn, by the way. But here, right, it was launched down initially, all right? So, and remember, you take the positive y-axis in the direction it's initially in. So the positive y-axis is actually, it's very unconventional, but the positive y is actually like this, right? Because it's going down. So you're going with the work of gravity. So it's actually just half times gt squared. So it's going to be 120 divided by 5, 24, radical answer, 4.89, 4.9 seconds. Done. Okay, now, the distance traveled, okay, here, this is a lot of formula for you to memorize, by the way. Don't ever press equal. It could be greater, it could be whatever, God knows. You have the time, right? And the distance traveled by the box, okay? You're gonna find, so, for this one, first of all, let's find the distance traveled by the airplane, okay? It's a bit easier. So, the distance traveled by the airplane, right? Since it's horizontal, okay, it's always horizontally, right? And it's always staying the same. There is no acceleration. So it's URM, right? It's URM, which means V equals what? A constant, right? So it's always going to stay 100 meters per second. Now, X is going to equal to VT. Delta X is going to equal to VT, right? So delta X in this time interval, 4.9 seconds, it's going to be what? 100 times 4.9. Right, 100, I can't write 4.9, okay. 490, 100 times 4.9 is 490 meters, all right? So, the plane traveled 490 meters. Okay, now that this has been established, there is no horizontal acceleration, right? We don't have horizontal acceleration, and we have no initial vertical speed, right? So, at all times, Vy, right, since it's gonna be 0, right? So, that means we're only concerned about the vertical speed, right? We're only concerned about the horizontal speed, sorry. So V of X, it's URM, right? So what is it? This is delta X. Delta X is equal to Vx times time. Vx is what? Whatever. Vx is constant. And we have it, I'm assuming. Yeah. Since it stays at 100 meters per second, again, there is no horizontal acceleration, right? And it's going to stay the same. So it's going to be delta X is equal to 100 times 4.9, which is literally the same exact thing, 490 meters. Done. Okay, so you can see it is equal. Now, the speed with the box reaches the ground, all right? So here, the box is gonna stay. Oh, by the way, the only reason I said Vy is equal to 0, this is wrong, by the way. This is wrong. And this part here, it's wrong. But what I care about is the distance, right? So it's always, I'm just going to be concerned about delta x, right? I'm not going to be concerned about delta y. No, there is at some point here, for example, right? At this initial point, there was Vy equals to 0. That's okay, this is true. But at this point here, there is a Vy. Alright, so it's not equal to 0. I made a mistake here, I just realized. But no, there is a Vy, but it doesn't matter. Why? Because it's distance. Distance is what? Delta x. Right? So I don't really care. And obviously it's gonna stay constant since it moved at 100 meters horizontally, and it's gonna stay at moving at 100 meters velocity. The helicopter, so it's gonna have the same as the boat, blah blah blah, whatever. Now the speed. Okay, the speed v of x, remember we said it was 100 meters per second, right? I don't need to find it, it was basically given to me. Okay, the vertical Vy is equal to what? Negative gt, or sorry, positive gt. I keep forgetting because it's so unconventional. Plus v0 sine theta t. Remember, v0, there was no initial vertical velocity, so this was 0. 0 times time is 0, so whatever. Okay, now we have the time interval, right? This is how much time it took. So Vy is equal to 10 into 4.9, 400, 10 into 4.9, 49 meters per second, right? Now you apply the magnitude of this velocity. So 100 squared plus 49 squared, 111.39, 111.35, so it is 111 meters per second. Done. Okay, question 17. Okay, for question 17 and 18, they're both relative motion and they're very, very easy. Okay, so now here, select the diagram that shows the direction in which the plane is moving to the ground. You can see that the wind is going like this and the plane is going like this. And we said before that, for example, from the man on the boat, the water will always push his boat. So he was moving like this. It will slowly move like this every second, right? So this will cause a drift, right? It will cause a drift, but obviously not a drift this big. Yani it's all gonna go like the wind isn't that big relative to this plane. It's not gonna push it that much down. It's only gonna push it very, very slightly, right? And then it's certainly not big enough to change direction. So these both are wrong. Now, the resulting speed of the aircraft relative to air is okay here. Relative to air, so you're taking the air as the frame of reference. This wind is already moving to air. This airplane is moving to relative to the ground, right? Relative to the air. No, okay. So you're gonna do radical 300 squared plus 50 squared. Okay, this gives you 304 meters per second, which is the correct answer. Now you might be asking me, okay, Tareq, why aren't we calculating the drift that this is pushing at? No, why? Because that drift is seen from the ground, not from the air. The air stays still, but from the ground you're gonna see it that the plane is gonna drift, right? So here, but the air, that's relative to the air. If it's relative to the ground, okay, then you're calculating the drift that is being on. But no, the wind is already moving relative to the air, and the plane is moving relative to the air. So, yani, realistically, you're not gonna calculate the drift. It logically doesn't make sense. Okay, question 18. This is where you're gonna have to calculate drift. Now, assuming moving at 2 meters per second perpendicularly, blah blah blah. Okay, the width of the river is 250 meters. Now the time it takes, remember, speed is distance over time, right? So this means that time is what? Distance over speed. So this equals to time is equal to 1250 over 2, 125 meters per second, right? So now, but here, realistically, because you're seeing it relative to this part, right? So she is not gonna move at a straight line, she's gonna move at a drift, right? So this means that when you calculate the drift, you have to calculate, alright, already you're gonna have 250 meters, but then you have to calculate the drift. The drift is how much? The river is pushing at this poor swimmer at a rate of 0.6 meters per second, right? For how many seconds? For we said 125 seconds. Every second it's pushing 0.6 meters away, right? So calculate it, 0.6 times 1.25, you get 75 meters, right? Now, add 250. Why is my fire alarm going off? Okay, whatever. I'm positive I'm not gonna die. 250 plus 75, 325. 1 second, I did something wrong. Wait, I just realized. Why did I add them up? You're not supposed to add them up. You're always supposed to find the magnitude. It's 250 squared plus 75 squared. I think this might give me 261. Let me just check. Radical 250 squared plus 75 squared. 25 vertical, yeah, 261 meters. Okay, this is the end of the quiz. Good luck, guys. Have a good day.